observations on Lily, just things that you may notice, okay? Are you ready? Okay, 3, 2, 1, freeze. And a round of applause, please. Now, Lily, continue sitting down there. Thank you, Lily. I see that you're ready to leave now. But would you want to stay in that bumper cart all day? Yes. You would want to stay in that bumper cart all day? Okay. Why? Okay, it's kind of comfortable. Lily, I'm sorry to break the news. You can't stay in this thing all day. Eventually, you're gonna have to go to class. You're gonna get hungry. We can't bring food to you here. So you're just gonna have to move. Now for this. Now, you understand this part, this moving part. We also need to talk about the second part of the first law of motion. Because the first law of motion not only tells us that an object that is not moving will not move unless a force acts on it, but it also tells us that an object that is moving will continue to move unless a force acts on it. So what is a force again? Yes? It's a push or a pull. Excellent. Yes. Now, for this second part, I'm going to need another ball. Come on. What's her name? I'm sorry? Thank you so much for coming up. Now, this is what I want you to do. I want you to sit on this little stool over here, facing down. Thank you. And I'm going to pull this bumper cart back. Right? And when I do that, I'm going to stretch this bungee cord. Now, what's going to happen when I stretch the bungee cord? Yes. So the bungee cord is going to come together, and that's going to move the bumper cart forward. Okay, excellent. So that's exactly what we're going to do. Now, you're going to be our anchor. You're going to allow me to pull the cart back, and Lily, and the bungee cord without having to drag all of that with me. So that wouldn't be too much fun. Now, hopefully, what I'm going to do is that I'm going to get some motion, get this cart going, and you two will high five. Okay? So I'll have you stick your left hand out, and I'll have you do exactly the same thing. Like this, yes. And hopefully you two will high five. Okay? Sounds good? Okay. Try this out. Ready, Lily?
Yeah, maybe.
3, 2, 1. Alright, so you got the motion there. That's good. Lily, turn around. Put it in the middle so all your classmates can see it. Excellent. So we got some motion, but the first law tells us that an object that is moving should continue to move unless a force acts on it. So the reason why this cart slowed down is because of a force. Now, what is a force again? Yes. It's a push or a pull. The force that slowed down this cart is called the rubbing force. Anyone here can tell me what is the rubbing force? Yes. Yes, so the rubbing force makes some heat, most certainly helps us in the winter. What is the name of the rubbing force? When we rub two things together, what is that? Yes?
Friction.
Friction. Friction slowed down this cart. Now that's a little bit of a shame. Because in reality, see, Lily, you say you wanted to be in this cart all day.
Yes.
Really what I want to do is crash the bumper cart against the tower of boxes. Now, in order to do this, we are going to need to talk about the second law of motion. Hands down, please. We're going to talk about the second law of motion. Now, the second law tells us that a force is the result of the mass of the object and its motion. Now, we've talked about the force, right? Force is a push or a pull. We talked about motion. We said that motion has to do with energy. What is mass though? Anyone here can tell me what's mass? Yes.
Does mass weight? Like
Mass?
Something is?
That's a very good thought. So mass definitely has to do with weight. Yes.
It's the. It's like the amount of and like the size of the object.
Okay, like the size of the object. I'll take one more. Yes.
The size and weight.
Okay, so it's a little difficult to explain, but mass is just how much stuff an object has. It's very similar to weight. I'm very glad someone brought it up. Weight is different than mass in that weight takes into account gravity. Now, gravity here on Earth is different than the moon's gravity. It's different than the gravity of Mars. It's different than Jupiter's gravity. So your weight in the moon would be different than the weight here on Earth. So it's slightly different. Mass, however, is the same. Doesn't matter where you're at. Mass is just how much stuff you have. So it's very, very similar. But mass is just constant at all times. Okay, so now that we've been through these three parts, what can we do? What can we do to crash the bumper cart against the tower of boxes? Yes. Okay, so I can take it further back. So if I take this cart and Lily further back, I would be increasing the force, right? I am stretching this bungee cord even more. I'm adding a whole lot of potential energy in here. And then if I stretch the whole thing, maybe I can get a greater pull. Have more force. If I have more force, maybe I can have more motion. So we're going to try just that. Lily, are you ready?
Sure.
All right. It's all the way back. I'm going to try to have you two high five once again. Ready? 3, 2, 1. Okay, that was pretty good. But we definitely hit the tower box. That was great. But this is the thing. I just want to tumble the whole thing. I want those tower boxes to just go down. What else can we do? Yes.
If you decrease the weight or the mass of the object, then it can go farther faster.
Okay, so you think, okay, that's a very good thought. What do you think?
You can bring that next to the actually you can see that next to the box and so it's fine.
Oh, that's a very good thought. So there are two things, these are two brilliant ideas. So one is I could bring these boxes way closer, like maybe over here, right? So then you would have an impact, a little less. Lily's saying no, so we're just not going to do it. But you also mentioned that we can also just decrease the mass of this cart. So I think we're going to do just that, because maybe if we have less mass, we can maybe have more motion. So that's a very good idea. It's a great prediction. So Lily, this is what I'm going to do. I'm going to ask you to please step off this cart. Thank you so much. I'll have you stand over here. Thank you. And now that we have less mass, we are going to see how this goes. Okay.
Set height.
Ready? 3, 2, 1, go. Okay, I know you guys all wanted to make it fall down, so we're going to try it one more time. And this time, I'm going to do what one of you mentioned, which was bring it a little bit closer. Maybe ready? All right, let's try this out. 3, 2, 1, go. All right, so at this point, let's give our volunteers a round of applause. Thank you so much. All right, excellent. So we have talked about the first law, the second law of motion. Now we're going to talk about the final and third law of motion. Now the third law tells us that forces come in pairs. For every single force, there is an equal and opposite force. Now what does that mean? So this basketball over here is not moving because of these equal and opposite forces. Now Earth's gravity is pulling this basketball towards the ground. But the reason why it's not moving is because the force of my arm is opposite, is pushing up, and it's equal. It's just the same as this basketball over here. Now, if I were to stand like this for a very long time, my arm is going to get tired. And at this point, the force of this basketball is going to be greater than the force of my arm. At this point, I'm going to be very tired, and I'll have to let go, and the basketball will fall to the ground. Something very, very similar happens when we sit on a chair or a stool. The reason why we don't fall down is because of these equal and opposite forces. My body is pushing down towards the ground, or I should say Earth's gravity is pushing my body towards the ground. But the reason why I'm not falling down is because the chair is pushing up and has an equal and opposite force that is keeping me from falling down. Now, for this next part over here, no one's going to get really tired from holding basketballs in the air or just have or anything really. But I will need a volunteer. I'm going to have I'll have you in the beer back. Come on. What's your name? Andrew. Thank you so much for coming up, Andrew. Andrew, these are your safety goggles. Andrew, stay right there for a minute while I bring this over here. Andrew, this is our task. This is what I want you to help. I want to move this sail cart over here forward in this direction, okay? And we're not going to use our hands. We're going to use something else. It's a little more exciting. I'm going to bring this leaf blower over. Have you ever used the leaf blower before? Excellent. Okay. Now, what I want you to help me figure out is in which direction should this leaf blower point. So you say that it should point in this direction over here. Okay, so that's a great thought. Anyone else have any other ideas? Yes.
It should face this way.
So you say it should face this way. Any other thoughts? Yes.
I mean, if you wanted to move it, like, if you wanted to knock it down, then you would probably put it sideways.
Oh, so maybe if I put it sideways, the force of this leaf blower could be enough so it tips over. That's a good thought, but we're not going to try this out because I don't want to break this because we only have one sail cart. What do you think?
You would push it, you would face it towards the left.
Towards here.
Yeah.
Okay, so we've had 2 predictions so far. We have to say that some of you think we should do it in this direction, some of you think in this direction over here. By a show of hands, who thinks we should do this? And who thinks that we should do this? kind of like a 50-50. So we're going to try both of them out. So we're going to start over here. Now, what I want you to do is to come over this side. So you see this over here? That's the switch. That's how you turn it on. Don't turn it on just yet. First, I'm going to give you this. It's going to be a little loud. So I'll tell you when to cover your ears. What I'll ask you to do, I'm just going to count down. 3, 2, 1. Then when I go like this, you turn on the switch. When I go like this, you turn it up. Sounds good? Okay, so let's put our ear protection on first. And I recommend that you cover your ears at this point. Are you ready? 3, 2, 1, go. Okay, so not a whole lot happened here. That is because these forces are balanced. So just like when I was holding the basketball in the air, or when we sit on a chair, there is not a whole lot going on there. Now we're going to try something else, which is what some of you thought that we should do. We're going to do exactly the same thing. I'll count down, I'll ask you to turn it on, and then when I go like this, you turn it on, okay? Ready? So ear protection on, once again. You can cover your ears if you want to. Ready? 3, 2, 1, go. Excellent. All right, and a round of applause. All right, so in this case, these forces were not balanced. Air that was coming out of the leaf blower was pushing in this direction, but at the same time, it was pushing in the opposite direction, and that made this sailboat move forward. If you ever use a leaf blower, you will notice that it kind of like moves back at you. Sometimes it surprises you. It's just those opposite forces that are at play. Now, you see the third law of motion all the time. In fact, we used to send rockets up to space. Rockets are packed with fuel, and when we burn that fuel, all of that fuel is going down towards the ground, but at the same time, it is pushing up. And that is what makes rockets go up to space. Okay, now we're going to switch gears and talk about work. Now, work in science is a little bit different. Work is a force, a push, or a pull that is being applied over a certain distance. So, moving this sail cart, I am doing work because I'm using the force of my arm, to move something over a certain distance. Now we're going to explore a little bit more of work. But first I need to set this up. Okay. This. I need one more thing. This over here. Excellent. Now, I'm going to need a volunteer. I'm gonna have. What's her name? I'm sorry. Ariana, thank you so much for coming up, Ariana. Ariana, this is what I want you to do. So first, let me go over this. This is an air cannon. And this air cannon, we're going to use it to just launch things in the air. Not you. You're good. This here, there's nothing too special about it. Just bounces. And this pin over here, Ariana, is going to help me control the distance. So, put it over here. Now, I'm going to use this bellows over here. Just kind of fall apart, so give me 1 minute. I'm going to use this bellows over here to push air to this hose, which is going to push air through this air cannon, and that's going to make this sphere move further away. Ariana, this is what I would like you to do. I would like you to position yourself anywhere in this room where you think this sphere will land. And I just want you to try to catch it. Okay? Now, I see that you're going further back, which is great. Let me just give you a little bit of space, because I don't want you to trip and fall over the mess earlier. Put this over here. Okay. Are you ready? Okay. So we're going to try this out. In 3, 2, 1. Okay, so not a whole lot happened. Thank you so much. Awesome. I want to do more work. I want to launch this sphere over more distance. What can we do? Yes.
You could put the ball back further.
Okay, so I could put the ball back further. What else can we do? Yes. Okay, I can set up things. So those are 2 different ideas. I'll have hands down for now. Those are 2 very good ideas. So we are going to try each one of them individually. So first, let's step on, right? So if I step on, I could add a greater force, right? And if I have a greater force, I'm using the force of my legs instead of the ones of my arms, I can do more work. We can launch this over a distance even more. So let's just try that. Ariana, once again, I'm going to ask you to do the same task. Position yourself anywhere in this room where you think this will land. Okay, I see that you're adjusting now. Are you ready? Okay, 3, 2, 1. Nice catch. Okay, so we did more work, for sure. Not a whole lot more, but we did more. But I want to do even more work. In the corner, yes.
Maybe you could put the pin that makes the ball stay further in the back.
Okay, so you just excellent. That's a great prediction that we can do. So maybe, and one of you mentioned that earlier, right? That we can move this pin further back. And if we move this pin further back, maybe if we have more distance, we can do more work. We can launch this a further distance. So let's try that. This is a great prediction. Ariana, same task for you. Perfect. You think it's going to land there? Excellent. Now I'm just going to ask you to try to catch it. Okay. Ready? 3, 2, 1.
It worked.
Nice. Excellent. All right, so we just added a tiny little bit of distance. I just added this much more. Just a little bit more distance. And we were able to do more work. We were able to use the force of my legs, to launch this a further distance. Now, some of you may be thinking, can we put this all the way back? Can we put this sphere all the way back? Now we're going to do this, but this is the thing. I did not come here to hit anyone with spheres. So Ariana, I'm going to ask you to step over here to this side, because I would much rather you not be in the way. Thank you. And we are going to see what happens. Now let me take this back even more. Adjust. Okay, I think now everyone's safe. Ready? 3, 2, 1. Alright. Ariana, thank you so much for coming up. Let's give her a round of applause. Alright, so just adding a little bit of distance helped us to do more work. Now, when we have a tool that can add more distance to do more work, that is what we call a simple machine. Simple machines help us do more work. Now, we're going to explore more simple machines. For this next one, though, I'm going to need 2 volunteers. I'm going to have you coming up, and I'm going to come on up. Awesome. All right. These are for you. Nico, thank you so much. And Avery, thank you, Avery. Nico, excellent. All right, so you two are going to be our contestants in the battle for work. Now, Nico, what I want you to do is to be over here. Avery, I'm going to have you come over here. Okay, now what I want you to do is basically we're going to, both of you are going to try to spin this wheel as much as you can. Now these wheels are connected. So what I'm going to have you to do is just spin them in opposite directions. Okay? Whoever spins the wheel the most will win the battle for work. Nico, I want you to spin this wheel towards this direction. Okay? Avery, I want you to spin the wheel towards the direction of the audience. Okay? Are you two ready? Okay? 3. You guys can hold on. 3, 2, 1, go. Nico, are you like having fun? Like just kind of like giggling quietly, easily? Just be Avery? That's kind of neat. And stop. All right, so Nico, that was pretty easy for you, right? Avery, you say your fingers hurt. I'm sorry. Okay, so anyone here has any thoughts, any ideas of why Nico won? Yes.
Maybe because the wheel's a little bit bigger and it's easier to carry.
Okay, so maybe because the wheel's a little bigger. Yeah. So what else? Yes. Oh, okay, I like that thought. So maybe because it's a little heavier, you can kind of like, it's a little bit more difficult. What do you think?
It's bigger and easier to grip.
There's a little bit of an easier grip. In the back, yes.
Since you're like a little stronger,
I'm sorry?
have like more strength than the other person. Like,
You just think that Nico is just strong. You know what? I'm glad someone brought it up, Nico. I was wondering if someone was gonna say something. I think that it's not strong. Okay, so now if you were the strongest 4th grader in the entire country, you would be able to win regardless of the size of the wheel. Right? Probably, right? So let's now swap. And let's see how it goes. So I'm going to have you two do exactly the same thing. So exactly, I'm gonna have you spin this wheel in this direction. Nico, I'm gonna have you spin the wheel in this other direction. Okay? Are you two ready? 3, 2, 1. And stop. All right, so why is it that people keep winning with big wheels? All the way in the back, yes.
Since the tiny one is tiny and that one is bigger, it weighs more, and if you try and spin it with the tiny one, it takes more spins. But since that one is so big, it just takes one spin to make the tiny one go around.
Excellent. So you notice that the big one, it just takes kind of like less effort to make it spin. What else? What else do people think? In the back, yes.
Bigger one has more force.
Okay, so maybe the bigger one we can do a little bit more force. Yeah. What do you think? Big one perhaps have less friction. That is a good thought. I don't know if that's true or untrue. That's a very good idea. I'm gonna have to think about that one. Anything else? Yes. Okay, so you guys have mentioned 2 things that are definitely have come into play. One is great. This wheel is a little awkward. It's pretty small and it's a little bit difficult to move around. But perhaps even more importantly is what many of you have mentioned, that it's just that it's the size. There is way more distance from the middle of this of the wheel to the side. And if you have more distance, just like our air cannon, if you have more distance, then it is way easier and you can do more work. So that's why people continue winning with that big wheel. Doesn't mean that you're not strong. Just pointing that out. Okay. Well, thank you two so much for coming up. Let's give them a round of applause. Thank you so much. Thank you. All right, so we have talked about quite a bit today. We have talked about there we go. Okay, so we started talking about energy. We talked about energy in terms of motion. We talked about different types of energy, different transfers of energy. Then we switched to forces. We said that a force is a push or a pull. We explored the 3 laws of motion. Then we talked about work. And with that, we talked about simple machines, which means we have only one more thing to do today. Anyone here remembers what was the last thing that we were doing? Yes?
Putting a teacher on that.
Yes, we are putting a teacher in that thing over here. At this point, I am going to need a teacher volunteer. Here on this over here. I'm going to give you a little bit of space to be funny with it. Now, this all well. Awesome. Okay. Have a seat, please. Now, once you're lifted up in the air, I'm just going to ask you if you can put your feet up here, and you got it. You can hold on to that. Perfect. Thank you so much. secure this over here. Yes. Perfect. All right. Okay. At this point, I am going to need a volunteer. All and everyone's hands up here.
Can I take a volunteer?
Sure, go ahead. Take one. Are you sure? Are you 100%?
Yes.
You're making my job even more difficult. This is the most difficult part of my job. There's a whole bunch of people wanting to come up. I am going to have. I'm going to have you in the pink shirt. Coming up. What's her name? Hannah. Thank you so much, Hannah, for coming up. These safety goggles are for you. Hannah, this is what we're going to do. We want to do this very smoothly, okay? We don't want to drop your picture. And this is what I want you to do. I want you to hold on to the handle and just, if you can, just very smoothly bring this lever bar all the way down, and then very, very smoothly we're going to bring it back.
Very smooth.
Okay. Sounds good, Hannah? Okay. Are you ready?
I'm ready.
Are you ready, Hannah? All right, are you guys ready?
Yeah.
All right, 3, 2, 1, go. And stop. Okay, so one person wasn't enough. What else can we do? What else can we do? Yes.
You could try to call up like a couple more people to help.
Okay, so we could have one more person. Would you like to come up? Yeah. What's your name? Derek. Thank you so much, Derek, for coming up. Derek, Hannah, we're going to try this once again. Now, let me just go over the rules again. Very smoothly, very gently, we're going to move this lever bar, if you can, all the way down to the floor, very, very gently and smoothly back up. Okay? Are you two ready? Are you ready?
I'm ready.
Okay, let's try this once again. 3, 2, 1. And stop. Okay, so 2 people wasn't enough. What do we do? What do you think? Okay, 3 people. Okay, that is a great idea. But hands down, I'm sorry. I know. I wish I could have every single one of you come up here and volunteer. I don't have more space. I'm just gonna keep the 2 people that I have there. So we have to do something else. Very good thought though. Because we would be adding more force. I like how you guys are thinking, but we can only have 2 people. What do you think?
That if you extend the bar with the features, it would be easier to lift them up or make it longer.
Okay, so you notice that we have a bar in the back. And you're thinking that maybe if we add more distance, we can perhaps, well, do more work. Just like what we have been thinking about all this time, right? Just like this air cannon over here, the more distance that you have, the more work that you can do. So that's a great thought, thank you. So we're gonna try just that. So it's gonna take me a minute over here to add this lever bar extension. This. More distance. And more distance. Okay. Now. This is secure. This part over here. There you go. Okay, thank you. All right. Adding more distance. Tighten this up so it's safe. So notice that we have more distance now. Is not so much that it's distance like this, but it's distance from the top all the way to the bottom. We used to have like this much distance, now we have this much more. So we're going to try this once again. So what I want you two to do is the same thing, very smoothly, very gently, bring this lever bar all the way to the bottom, and then very gently bring it back up again. Are you two ready? Yes. Are you ready?
I'm ready.
Are you guys ready?
Yeah.
Excellent. All right. 3, 2, 1, go. All the way down here, I'm going to have you move so you don't get squished. There you go. And very gently back. Yeah. And a round of applause, please. And a round of applause for our Thank you so much. All right, so we added more distance to this super lever, and with adding more distance, we were able to do way more work. All right, friends. So at this point, I want to thank you guys so much for being a great audience here today and doing some science with me. I work in the Museum of Science. You guys mentioned that your favorite, or one of your favorite activities to do in the Museum of Science was watch the lightning show. Well, guess what? When I am in the Museum of Science, which is more often than not, I do the lightning show. And I do other shows. I do live animal presentations. I'm always on the stage talking to people. So if you go to the Museum of Science and you see me, come say hi. And maybe we can talk about some lightning or maybe some courses. I like it when people say hi. I'm not looking at every single individual because I see way too many children on a regular basis. But if you see me, do come and say hi. I just thank you for being a great audience once again. Just now, look at your teachers. They will tell you what to do next.